We have two main speakers this morning, plus, of course, Minister Anglin and President Borden of UCCI. And then we'll have a short break to be followed by other speakers on plenary sessions this afternoon. It is my honor, therefore, to ask President Borden of UCCI to give opening remarks.
Thank you, Mr. George, and good morning again, ladies and gentlemen. I shall tell you, as Henry VIII told each of his wives, I shall not keep you long. So permit me to say that I offer again our heartfelt welcome and appreciation that you took your time to support us by your attendance at this conference. And I especially welcome our student ambassadors, because we believe that you should be the beneficiaries of this, our first conference on science, technology, engineering, and mathematics. But I want also to add to that special category of welcome the teachers and the instructors, because we hope that this can be the beginning of a partnership with you. And certainly, I know the minister will reiterate, and he can speak for himself, the ministry is most important in the promotion of any knowledge, no less science, technology, engineering, and mathematics. This is an exciting time at the University College, because with the building and development of our observatory, we have launched out on a projected path to promote the sciences, what used to be called the natural sciences at the University College. And so we have already started. We are the second year into a degree, an associate degree in engineering technology, which we will be partnering with a North American university for our students to begin their third and then complete their fourth and final year, which will lead them to a Bachelor of Science degree in engineering. And so I welcome you this morning, and I declare this STEM conference, Carib 2012, open. Thank you.
Thank you, President Borden. And now, ladies and gentlemen, it's my pleasure to invite the Honorable Ralston M. Anglin, Minister of Education, Training and Employment, to provide a few remarks. Minister Anglin.
Good morning. President Borden, I think your audience and participants may be asleep. Good morning. I was interacting with a few of the students a little earlier, and I can say that thinking back on my high school years just a few years ago, it's always exciting to have a day away from school, right, students? I see the nods, that's for sure. But it's equally important that that day away from school and out of the classroom is one that will be rich with knowledge and new information and ideas that hopefully will pique your interest, add value to what you take away from school, but most importantly, what you add to school. Because students, you are the heart of your school. And what you add and what you bring to the table is crucially important. Yes, your teachers are the instructional leaders, but at the end of the day, how rich your campus is in the student life is driven by you, your performance, your interests, and how far you stretch your own capabilities. And I am ever confident that all of you will do just that and continue to do that at your schools. President Borden, our visiting guests from overseas and speakers, faculty here at UCCI, it is certainly a pleasure to be here with you at this, the first STEM Carib conference that is being put on by our University College. Why is it important for us to have this sort of discourse? Well, the fact of the matter is, in a world that is scarce on resources, and resources are diminishing, science and technology will continue to play an ever important role in mankind's survival on this planet. The fact of the matter is, the vast majority of the problems that are going to face future generations are going to have to be solved in large measure with technological innovations. How mankind can innovate is going to drive future lifestyles for all of our future generations. We happen to live at a rather opportune time because there still is, relatively speaking, an abundance of natural resources on this planet. Where will fossil fuels be in 100 years from now? What of scarce water resources? Land. The actual footprint of our planets and our islands. Technology and how we innovate as humans is going to be ever increasingly important. The ministry fully embraces raising standards and creating awareness and information in STEM. In our new school, we certainly provide modern facilities that are second to none to ensure we can continue to drive performance and experience for our students in STEM. However, we've also ensured that at all stages of our education system, we incorporate technology. In fact, at our further education center, we have infused a wide array of technological-led type courses, such as one that is geared toward auto mechanics, medical technicians, and electrical technology. I am happy that we've also managed to have great collaboration that I hope will continue to increase over the years in terms of outsiders and their participation in our system to assist us in driving the performance of our students and actually enriching their performance in schools. Our local Society of Professional Accountants have been a key partner for us in mathematics in our compulsory school system. And so it's those types of partnerships that is going to continue to build capacity and enhance the experience of all of our students in compulsory education. I'm also happy, as the President alluded to, at UCCI's leadership in this front. He mentioned one of the courses that they offer, but they also offer accounting, business, IT, and environmental science degree. And that is important for our local college to continue to provide ever-increasing pathways so that our students and mature learners can have more and more opportunity to be able to embark upon STEM and STEM-related type study. Caymando does boast a rich heritage. From our very early days, we produced some of the best master mariners in the world, so much so that Cayman became the recruiting ground for a number of large shipping companies. If that were to happen today, it would be impressive with a population of 55,000. Consider how impressive that feat was when this was happening 70, 80 years ago, where shipping companies were seeking out seamen, not just able-bodied seamen, but master mariners and engineers from this tiny community. We had a rich heritage in shipbuilding. Some of the greatest ships were built here in Cayman, a forgotten piece of our history. One that I can say, I often think back and I lament and I say to myself, how could we have gone from being in the early 1900s, being a community that could build some of the greatest vessels, and by build I mean from the planning right through production and launch of some of the greatest vessels to sail the seas. Many families from overseas came to our shores with their idea of what they wanted their vessel to look like. And our technicians plied their trade. And as the old custom would go, they would give them a model, you'd cut it in half. The owner kept one half, our master builders kept the other. And at the end of the day, that was what determined whether or not they produced a vessel that the owner was going to make final payment for. So I want us to understand that Cayman does have a very rich heritage in many areas of technology, and that started many years ago. I'm also happy that the ministry is involved with a number of apprenticeship programs. We have an apprenticeship program right now with one of our local mechanic shops that is about to become a certified center for Jagas. And that is going to be another key achievement, and we want to roll those sorts of programs out with more and more businesses, because the more opportunities we give for all of our citizens, in particular our young people, to take up careers in the widest array of technology and technology-led professions, the better off our community is going to be. As I was coming here this morning, and I had a few points that I wanted to ensure I didn't miss. And as I looked at my smartphone, I couldn't help but reflect on the fact that when I was in high school, I had a computer that was the envy of my class. It was a Commodore 64K. How many of you remember the old Commodores? Yes, I see a few hands. That gives away something of your age. But anyway, a Commodore 64K, young people. And that was the business. And now we have stick discs that are about that small. The most recent one I got from my daughter, holding 32 gig of information. And of course, my Commodore 64K was a fair-sized machine, shall we say. How many of us remember the good old days of 5 1/4 floppy disks? Tape. Then we went to 3 1/2. Where are the floppy disks? Technology is moving at the speed of light. It is changing our lives. It has changed our lives immeasurably. How we in Cayman go from just being a key participant in using technology, because I think there's some statistic that says that BlackBerry, we have the highest BlackBerry penetration per capita in the world, apparently. I don't know where that information came from, but it's knocking around, so I'll just jump on board and do the old good Caymanian tradition and spread the rumor. But needless to say, I think you would be hard-pressed to find any family, irrespective of economic status, in today's Cayman that doesn't have a smart device in their household. And so just wrap our minds around that and think back over just over a very short window, the last 20 years, of how much technology has changed our lives in Cayman. But we need to move from just being participants and users to innovators. Cayman has all of the talent, and as I look at all these students residing in this hall today, is a small portion of the students who have the capacity to develop the next great app that is going to be used by users of Apple and other smart, Samsung and other smart devices. We have that type of brain power within our small island. So students, I hope for you the experience here to be one that will be rewarding and inspiring, that will drive you to unearth within yourself all of your potential, because every one of you can be a great innovator if you put your minds to it. And our community has embraced technology and STEM. In fact, I think it's Minds Inspired, did I get that right, is a scholarship that's offered by one of our local companies, and one of our recipients in the very first year is here with us today. And so not only is the ministry and schools taking this important, not only is it being taken important and a key area of priority by the University College, but it is a key area of priority for our business community. So I hope and I wish that this conference will exceed expectations, Mr. President, and will be a key on the annual calendar of UCCI. Thank you.
Thank you, Honorable Minister. And ladies and gentlemen, let me send regrets from the Chief Officer in the Ministry of Education, Mrs. Mary Rodriguez, who is unable to attend. Minister Anglin, you have articulated the importance of technology, science, and mathematics, in particular to young Caymanians, and then you have articulated that Cayman continues to provide as much resources to aspire young Caymanians in achieving aspirations in that area. Okay. You have also mentioned that Cayman is attempting or continues to build capacity, opportunities, to provide opportunities, okay, and providing facilities in particular in the various schools. And I was listening to the talk show on Monday in which Doctors Guinan and Hack and I believe Dr. Parker also. And there was a clear indication also that while the technology, the concepts have not changed over many years, it's the question of how do you engage students in the various schools, and how do you change the methodologies to deliver such know-how and knowledge to young students. So I believe also perhaps these are some of the challenges that not only Cayman but also students from all around the world would have to address. Ladies and gentlemen, we have with us, I like to call him a man of many hats from having read his bio, Dr. Edward Guinan. Dr. Edward Guinan is a PhD by academic profession. He is also a professor in astronomy and astrophysics at Villanova University. And it's interesting, folks, he and his colleague discovered Neptune's ring in 1968. So, and he continues as I'll mention in a while. His research interests include binary star systems, black holes, and we've been hearing about black holes for many years, many of us. I'm still trying to figure out what it is. Evolution of the sun and solar-like stars, pulsating stars, astrobiology, exoplanets, and I'm sure he'll explain many of these, and the suitability of exoplanets for life. He's a guest investigator on a number of NASA astronomy space observatory, including the Hubble Space Telescope, Spitzer Space Telescope, Chandra X-ray Observatory, XMM Newton X-ray Telescope, and Kepler Planet Quest mission. Dr. Guinan has published over 500 science papers and edited over 4 books. He's also the chair of the Teaching Astronomy for Development program at the International Astronomical Union, which sponsors education, research, and outreach programs in developing countries. It is interesting to note that he has also served on numerous NASA and National Science Foundation advisory panels, and currently serves on the Council of the American Astronomical Society and is the chair of the U.S. National Committee on the National Academy of Sciences and Astronomy. Dr. Guinan is an advocate for space travel and is a founding member of the Star Voyager project for human interstellar exploration, and has also served on the advisory boards of the Lifeboat Foundation and the International Space Development Hub. Ladies and gentlemen, it's my pleasure to invite Dr. Guinan.
Thank you very much for that nice introduction. I didn't realize that was me. And I wanted to thank Bill and Shireen for inviting me to the Caymans, and for the support of the President, of Roy Bowden, and the Science Minister. I hope you're going to enjoy the conference, and I certainly am. So today, what I'm going to be talking about is, let me get these going. Oh, that's my first slide. I'm going to use a portable microphone. Is that all right? Yeah. So let me switch over. No. Hello? Okay, so I'm going to be talking about a project we have. It's called Assessing Suitability for Nearby Stars, and whether they can have life or not. And a major discovery was actually made yesterday, and that our nearest star to us, Alpha Centauri, 4 light years away, has an Earth-sized planet. So this is it's not a planet you want to live on. It's 2,000 degrees Fahrenheit, but it's the first time that system has been shown. So it's the nearest planet to us, was discovered just 2 days ago. So there we go. This is like talking points, we'll call it. Introduction to finding these planets. Exoplanet, by the way, is a abbreviation for extrasolar planet, a planet outside of our solar system. And now there are 3,000 of them known, and there are billions that yet to be discovered. I'm going to briefly talk, the technical part of my talk is talking about red dwarfs. Red dwarfs are stars like our sun, but very little. But they occupy 80% of the stars in our galaxy, or our universe, are these red dwarfs. I have to be very careful I don't go right in there. And then extraplanetary systems. Then the nearest star system that seems to have life is this one called GJ 581. And that's a red dwarf star, 20 light years from us. Let me give you an idea. 1 light year, okay, is 6 trillion miles. So a light year is the distance that light travels in 1 year, and light goes very fast. So this is the way, usually instead of saying 60 trillion or 100 trillion or a billion or a gazillion, astronomers like to use light years as a unit. You have to remember it's 6 trillion miles, so that's not near. And then the last part will be on getting there. How could you go to these stars? So this is like interstellar travel, and that's a new thing. There's a program called the 100-Year Starship, started by NASA, that in 100 years they're hoping to go have a human mission to visit Alpha Centauri. And in 30 years to Mars. You'll see when I talk about that, it's very costly. And one of the reasons for going is to have a copy or to spread human nature, humankind, our species. Could be that the Earth could be hit by an asteroid, or a black hole could come in and disrupt the solar system. So one of the ideas here, it's a backup, is that we get people out of the solar system and colonize another planet. So a brief talk is finding exoplanets. This is very brief, because this is a whole talk on its own. So exoplanets, again, are planets outside the solar system. And how you can find them, 2 ways. There's many ways. One way is to, if I get this working, let's see that little red. So here's the star, and this is the planet. You never see the planet, it's too faint. But what you see is the star moving. And as it goes in this direction, it has what is called the Doppler effect. It red shifts, blue shifts, and as it goes around as it goes around the star, it pulls the star slightly. So you end up what is called, this is velocity or speed, and this is time. So what you see here is the star coming toward you, and it's in units of meters per second, the star going away, and this is telling you that it's being pulled on by a planet, a tiny planet. So the star will wobble. It will go like this. It'll just come toward you, it makes a red shift in the spectrum, and it goes away and shows you a blue shift. The only way it can do that is gravity. If that didn't have a planet, the star would just be fixed. So it moves, and that's how you detect it. Sometimes you might hear that here if you're driving quickly and somebody blows their horn. You'll hear a high pitch as the car approaches you, and a lower pitch when the car goes past you. Hopefully it doesn't hit you, you won't hear anything. But that's called the Doppler effect. The other way is what Kepler mission does. Kepler mission is looking for eclipses. The planet goes in front of the star and produces a loss of light. So here you have the planet going in front of the star. Here's a picture of it. And as it does so, it causes the light of the star to diminish. This is only like 1%. It's a very, very small change. And this, some of you have seen the transit of Venus here a year ago, or not a year ago, but in June. And this is what happened in our own solar system, is that Venus went in front of the sun, and you could visualize it. Now again, with stars, they're so far away, you can't see this. What you see is the light losing, the light loss here. And for an Earth-type star, it's very, very tiny. It's 1/10,000th loss of light, because Earth's bodies are small. For Jupiter, it's 1%. Let me give you the census. This is 2 weeks old. I have to keep updating this. This is the exoplanet census, September 2012. If I had some time, it's probably higher. It goes up all the time. Confirmed exoplanets. These are planets outside the solar system from using these two effects, the Doppler effect, the pull of the planet, the gravitational force of the planet on the star, and the transits when they move in front of the star, 660 plus. I put the plus there because it's probably higher. The candidates that need to be confirmed, over 2,000, mostly from the Kepler mission. Now what they've done is they've taken the census that Kepler has made, and they have extrapolated how many planets there are. It turns out that about 1 out of 4 stars in their sample seems to have planets. Many of those planets are multiple. Like our own solar system, we have 8 planets. We used to have 9. And the 8 planets, so when you count these up, it turns out that they expect to have about 50 billion planets in our galaxy. It's a lot of planets. So some of those planets are actually thought to be loose. They have escaped from their host star, and they're just zooming out in space. You don't want to live on one of those. There's no sun, no star to give you heat. But there's a worry now that some of these planets may be out there and not visible, and some of them could be coming in toward the Earth. That's one of the reasons for interstellar travel, is if a large planet like that came in, it could disrupt our solar system. It's very unlikely. Finally, down the bottom here, the number of known planets with life, 1. That soon may change, because the rovers on Mars are digging into the Martian soil, and they have found water, ice. They haven't found any life yet, but possibility of finding fossils of previous life on Mars. Mars, 3 billion years ago, had water flowing on its surface. It underwent a major climate change from a very warm planet to a very cold planet, and most of the water had escaped, or the remaining water is ice inside the planet's surface. So I think there's a good chance, 50-50 chance, of finding life on Mars, but it's not going to be alien. You know, it's not going to be green people and things like that. It will be bacteria, probably. Okay. This is my program, and I'll spend just 5 minutes on it. This is technical. This is called Living with a Red Dwarf. In the United States and elsewhere, all over the world, you have to give this is a proposal for NASA, and you have to give it kind of an appealing name. It's like a book, you know, a cover of a book, or a movie. You give a movie a good name, and people will come, you know, like zombies and things like that. So we called this, instead of investigating red dwarf stars, we called it Living with a Red Dwarf. And then the program there was to study these red dwarf stars to see if they were suitable for life. Again, one of the logos we made, you have logos here for the STEM meeting. The original logo we had was this. The one we had to get rid of was this one, Living with a Red Dwarf. We thought this would be a good logo, but it has some problems. So this was dropped. So actually, we never thought of this as a logo. This is a joke. But what you have to do is find a good selling point for your proposals. And then we find when we have a proposal with a name and it has appeal, it has a higher chance, even though the science is exactly the same. Now this is red dwarfs. This is a list of stars. In astronomy, astronomers classify stars as A, A, B, no, what is that going to be? Yeah, A, F, G, K, M, so on. The sun is a G star. These are stars like the sun. The stars in here are more massive than the sun, like Sirius, the star you see in the winter sky, is in here. So if you look at the stars within 10 parsecs, that's 32 light years. Within 32 light years, we know all the stars there. You see that this group in here, which is the red dwarfs, these tiny, faint stars, are the most numerous stars in our galaxy. They make up 80% of all the stars. So we thought, or 75%. So what we wanted to do there is seeing if these stars could harbor life, if they were suitable for life. And that's what the program's about. This is a picture of all the stars within 16 light years of the sun. And we see that the sun is in the center, of course. It maybe shouldn't be, Sol. And then you go out 5 light years, 10 light years, 15 light years, and this shows you where they are. Alpha Centauri is right here, is right down there, which is the nearest star. Most of the stars in that picture, who I won't go and renumerate their names, are red dwarfs. It's a little dim to see this, but what are red dwarfs? These are stars that have masses of 10% to half the sun. So they're small mass stars. They're cool. 3,700 degrees Kelvin is 6,000 degrees Fahrenheit. So they're not, the sun is 12,000 degrees Fahrenheit. So they're cool relatively. They have, the major thing here is that they have very low luminosities. That is, the amount of energy they put out is 1/20th or 0.5% of the sun or less. So they're very dim. They're hard to see. And that's going to play a role, because if you want to live around one of these stars, you have to get close to it. If you want to have a planet that has similar conditions to ourselves, that we're 93 million miles from the sun, in these stars you have to be almost on top of them, 10 million miles, to be warm. It's like a fire. You have a big fire, a bonfire, you can stay away and be warm. These stars are like a match, just a match. So you have to get very close to be warm, but when you get close to a star, some problems can develop. The other properties in there is that one of the major things is that they live forever. They burn their nuclear fuel. That's why they're dim. They burn their nuclear fuel millions of times less. Now, stars, like the sun, is shining because there's thermonuclear reactions taking place in the core. Hydrogen is being converted into helium. That's the hydrogen bomb. In the sun, there's billions of hydrogen bombs going off in the center, and that gives us the energy source for the sun. These stars, the reaction rates are very, very slow. So the sun lives 10 billion years. The sun is 5 billion years old now. These stars live trillions of years. They actually can live to the end of the universe. When the universe starts to fall apart, these stars can still be there. That's an advantage, because some of these stars are actually near us. Some of these within 5 light years of the sun are 2 billion, 3 billion years older than us. So if they had planets, and if these planets have life, the life on those planets could be 1 billion years ahead of us. Who knows? So that's something to think about, is that these stars are older than the sun. If they have planets, it could be interesting. Sentient life, or life so advanced, it's like science fiction. I'll get to the next, just skip the rest. So here's a comparison of their sizes. The sun is drawn here on this. Ooh, that was the wrong button to press. I am going. This is counterintuitive. I have to go back. Let me go back to where I was. Yeah. This guy here. This is the sun on the left-hand side. And you see that they call these stars red dwarfs. We call them also M stars. And so you see they vary from about half the size of the sun down to the dimmest one on the right-hand side is 1/10 or less than the size of the sun. So they're little stars. This is a comparison of their internal structure, which I blew these up. They have different structure than the sun has. They have convection, bubbling. It goes right down into the center. So this is this is Proxima Centauri, and that's the sun. That gives you their scale. This is showing you the lifetime. These are computed by models of the stars, how fast nuclear fission happens. And what we see along here is that this is age in billions of years. This is 5 billion, 10 billion, 15, 20. And this is the luminosity on a log scale. A log scale means you go from 0 to 1, you're going up by 10 times. So here's the future of the sun. The sun is slowly getting bigger and hotter and more luminous. And we get to 4 billion years from now, the sun goes very, very large and becomes a red giant. Now, the red dwarfs don't do anything. They just sit, they slowly change luminosity. So in about 1 billion years, the sun is going to get too luminous for us to live here anymore. The Earth will begin to lose its oceans, and life will be very precarious for humans. I'm sure we'll be able to, we have 1 billion years. I told my students that it was going to happen on 2012, in a few months, but it's 1 billion years. In astronomy, that's not a long time, but in our lifetime, 1 billion years is huge. And this is the habitable zone. This is showing you where the habitable, this is what if you want liquid water, which a lot of people believe you need for life, what you need to do there, this is the solar system is this guy. So let me press the right button. Here's the sun. In our own solar system, the liquid water zone extends about where Venus is, a little bit beyond it. Here's the Earth's orbit, out to about double. An astronomical unit is the distance that the sun is from the Earth. So this is 93 million miles. So in our own solar system, you can go from about where Venus is to about Mars is here, out to about 2 times that. You have to play around with atmospheres. For example, if we exchange, Venus is very hot. Venus lives in here. But it's because it has a large greenhouse effect. So if you exchanged Mars and Venus, they would both be habitable. Unfortunately, you can't do that. So Earth is the only truly habitable planet. Mars is habitable, but it's cold. It's colder. Venus is not habitable because it has a runaway greenhouse effect. Okay. I'll get into it back to here. Now let's go and visit the nearest stars. So I'm taking you back to this. We will look into, I'm skipping some slides because they're kind of technical, and I've decided to go with the audience here. I see a lot of students who probably know more than the older people, but I'll go on. So this is the sun, and what we're going to do is look at some of these stars to see if they're suitable. And this is what the program is about. So let's go to Alpha Centauri. Alpha Centauri, have you any of you seen Avatar? And Avatar takes place, did you know it took place on the moon in Alpha Centauri? Did you know that? Did you raise your hand? No. Oh, that's the movie, the setting takes place on like a Jupiter-sized planet, but one of its moons is habitable, and it has these blue guys living there. And Earth, this is like maybe 200 years from now, Earth people have gone there to actually cause trouble. And so that's Avatar it's fictional, it's science fiction. So Alpha Centauri, you can not so well see it from here. You go a little bit further south, you can. It's, can you see the Southern Cross? Yeah, oh. Slow, but you can see. Southern Cross is one of my favorite things. And so if you go to the Astronomical Society and visit there, they have a meeting every month during new moon, you maybe can see the Southern Cross. It's coming up in a few months. So here's the Southern Cross. Alpha Centauri is here. It's a very bright star because it's nearby, and it's a double star. So this is a picture. And how far, here's 1 light year again. 1 light year is about 6,000 billion miles. So this guy is 4 times that. So you're talking like 20 billion, 25 billion miles. So does it have planets? Well, the answer was no until a couple of days ago. I mean, this was, it's a double star system. Actually, there's 2 stars. Alpha Centauri A, that looks like the sun, Alpha Centauri B, which is slightly less than the sun, and they orbit one another in 79 years. A lot of people thought that is, and there's a third star. Let me get into that one. There's the third star, which is actually the nearest star to the sun, and that's Proxima Centauri. That's a red dwarf. That's the one I was interested in. So this is slightly nearer by a few tens of millions of miles, because so this is a triple star system. These two guys orbit, this guy orbits around those two. And so we were very interested in Proxima Centauri to see if it had planets or not. But the idea in theory says that this Alpha Centauri should not have planets, because it has the two stars orbit one another so closely that one star would steal. This is Alpha Centauri A, this is Alpha Centauri B. They have what is called an eccentric orbit. Their orbit is like a big ellipse, so they come very, very close to one another, far away. When they come close, the one star can actually pull the planets off the other, or prevent planets from forming. So the idea here is planets wouldn't be feasible there. They'd have to be very close to the host star. And people have been looking for planets with this star for the last 20 years. The techniques have become very, very precise. They're able to measure the motion of the star to 1 meter per second. So that's like this fast. If the star is moving this fast, you can detect it. And 2 days ago, it was detected. So, breaking news, if you go onto Google, any of the sites in the newspapers, this is a major discovery because this is the nearest star. We can get to it. It was thought not to have planets. And this is a picture. This is not a real picture. This is an artist's picture. So here's Alpha Centauri B, the little dimmer star. Here's Alpha Centauri A, so you're looking at it from the planet's view, and this is the planet. It's a planet that you wouldn't want to live on. It orbits the star in 3 days. So it is very close to the star. It actually shouldn't even be there, and it's not going to be there forever. It's probably going to fall into the star. So this is not a habitable planet. The habitable zone around this star is about where Venus is in our own solar system. So the idea here is you find this planet, which is very hard to detect. It may have other Earths, and the size of this planet is the size of the Earth. So this is the nearest Earth-sized planet known. It is not a planet you would want to go to unless you like to have to be burned. It's like hotter than a pizza oven there, but it might have other ones. So this is a really big breakthrough, and that maybe we don't have to go as far as we thought to find life. And maybe Avatar is right. Maybe they're, because they were orbiting. Sometimes science fiction comes out to be true, many times. Proxima Centauri is the star that I worked on. It is a dim red dwarf star, and it is the nearest star to the sun, and that you need a telescope to see. It has no planets, unfortunately. None have been detected down to one Earth. So this is Alpha Centauri, Beta Centauri. This is how tiny this guy is. Its habitable zone is 4% of the distance to the Earth. Earth is 1 AU. This is 4%. You have to be very close to it. So that's Proxima Centauri. Our study shows that it doesn't have planets, at least that we've detected yet, but it is suitable for life. Barnard's star is another choice. I jumped ahead. Barnard's star is so close to us that it moves. And so this is the second choice. Again, detailed studies from using those methods, radial velocity, Doppler, transits, finds no evidence of planets here to 2 times the mass of the Earth. It could have planets like Earth, but they haven't been detected. They may not be there. The third choice is a fun one. Anybody in Star Trek fan? Any Star Trek Trekkies? I think most of you are too young for Star Trek. This is a very famous star in Star Trek. It's called Wolf 359. It's the third nearest star. and it's a red dwarf. It's very faint, and we've been looking at this for planets, and one of the famous things about this star, if you're a Trekkie, is that there was a major battle that took place in the year 2367, where the whole Federation of the starships of the Federation in Star Trek were massacred by the so-called, these are the Borg. This is a technical, so you have to be a Trekkie to get this. And I noticed the age of the audience just looking blank. Avatar works for the younger people, but this is, if you're a Star Trek person, this has its own website, this star. Then you go further. Epsilon Eridani is another star that actually has a planet. It's a big planet. Its size is it's 1.5 times the mass of Jupiter. So it's bigger than the biggest planet in our solar system. And it orbits the planet and orbits the star in 7 years. Now the trouble with this star is that it's young. It's 6 million years old. Our sun is 4 billion years. So in this star system, what you're doing is that you're looking back in time, like in our own solar system. 4 billion years ago is when the Earth was forming. It had formed, but it had asteroids and comets. It was called the collision, the age of bombardment. The Earth and all the planets were struck by debris. So comets falling in. So this is kind of neat. You wouldn't want to live there, and it wouldn't have life because it's too young. But it's an interesting planet to study, or system to study, because it gives us a way of looking back on our own solar system 4 billion years ago when the Earth had formed, but it was a bad time. I mean, you see movies, you go back, like in a time, never go back in a time machine 4 billion years. You will not be happy. The Earth has no oceans. The Earth is molten, lava, volcanoes going up, no life whatsoever except in your time machine. Hot, and raining down comets and asteroids hitting all the time. So you'd be running around and then you move and then things would come up and you wouldn't last very long. Your time machine would probably be destroyed. But I saw a movie where a person went back in a time machine and dinosaurs were there. And I don't know how that happened, but so this would be a fun system to study, and it is, because of the asteroids in it. So that's called Epsilon Eridani. You can see it from here. So now I'm going to go further. In TV fame, again, this is a little older. For the Babylon 5 took place on this star. This is supposed to be the home of Vulcan. It isn't. So this is where Mr. Spock supposedly was born. That's not true. Now we're going to go to the one that actually has a planet. So this is called Gliese. Gliese was an astronomer, a German astronomer, worked about 60 years ago, and he cataloged stars. He had a telescope, and he counted stars and gave them names. Of course, he gave them his own name, and so this is called Gliese 581. And there's about 2,000 stars with this Gliese name. This is a red dwarf. It's 20 light years away from us, so it's pretty far. But it has been found to have 6 planets. And 2 of those planets, or 3 of those planets, are in or near the habitable zone. So if I had to go someplace today, this is where I would go. Although it's not the best choice, there might be stars found that are better. This is the system. So here you have what I've done here. What has been done is that this is to scale. This is our solar system. This is the sun, say. Earth, 1 astronomical unit, 93 million miles out. This is the Gliese system, is up here. So it has these planets that they number, B, C, G, and so on. So it's a smaller system than our own. How you find this is that you find it by Doppler effects. Each of those planets is pulling on the star. Some pull quickly, the short period ones. Some pull the star in a longer period. So what you have to do here is you collect the data, and then you do an analysis of the data. It's not so hard to do, really, to pull out of the data all these things. This is due to the more massive body. So this is the star being pulled towards you and being pulled away from you. And the bigger the planet, the larger the amplitude, the larger the pull will be. So the bottom line here is you have to take lots of data and then you end up with a picture like this. So this is the system, the red dwarf, and then the stars. They're not in order of distance, so D, C, and G. G is a planet about the size of the Earth. Okay, are we okay with this? Okay. What happened is that what people have found, it's very hard to detect an Earth because the Earth pulls the sun only 1 centimeter per second. So we don't have the technology yet to really detect an Earth mass planet. So what's showing up is the kind of the tip of the iceberg. We're seeing the iceberg, which you don't have around here, sticking up. And below that, there's probably a lot of Earths. But what we're detecting is the easy ones, the more massive planets, because they pull on the star more. So they've detected a whole class of planets that are called super-Earths. And super-Earths are planets that have masses greater than the Earth. So I'll just take you through a couple of those. This is the Gliese system, and I'll just take you to the bottom line here. It contains B, C, D, E, and F. See that part that's blue? This part that's blue is the habitable zone. So you have D, G, and C, and all these are planets about 4 or 5 times bigger than the Earth. So they're called super-Earths. That means they could be habitable. You could live there. You need to have strong legs because the gravity is stronger. And a lot of the criticisms that why you couldn't live there is because the planet would be tidally locked. The planet is so close to the star that what happens is that the gravity causes the planet to rotate at the same speed that it revolves. Our moon does that. So you would have one side would be always facing, this is the planet, facing the star, and one side would be in complete darkness. And they thought that would be bad, because what would happen is that the atmosphere of the planet, if it had one, would condense in here and be ice, and this side would be a barren desert. But that's down here. This is what they thought would happen. What probably happens is that you get circulation. The hot part of the atmosphere rises up, creating a low pressure, like our equator, and this would be like our pole, causing a circulation that brings warm air over to the cool side and cold air over into the warm side, making this side reasonable. So the bottom line here is this is the temperatures you get when you do the modeling. This is not bad. I put it in 2 scales. I thought you used the centigrade system here, but I stuck this in. 50 to 97 degrees is not bad. You know, it gets this hot here. It doesn't get this cold, but that's not bad temperatures. It's sort of what you get in the Caymans. But this side would be much too hot. This guy, you know, that's even hot for here. 194, a little hot. So this is the modeling that the life would have to live on the dark side and probably get their energy from the lit side. Maybe what would life look like? Well, you need strong legs. The gravity on this planet is 2.5 times the Earth. So you need like the Hulk, big, strong legs to stand up and move around. The other problem would be is that it could be dry on the dry side, too hot. Other problems is the high surface gravity. You might have problems if you put a pussycat there with the gravity that the cat would have a hard time walking around. Getting there in the last 5 minutes. This is quick. So how do you get to these places? This is what could be part of the STEM program. Getting there is half the fun. It's actually all the fun. And this is how chemical rockets, hydrogen bombs, antimatter, ramjets, there's all kinds of ways that people are looking into. This is a very exciting area. This brings in engineering, because how can you travel to the nearest star? It will take you, going at normal speeds, will take you 500 to 1,000 years. So so I have to tell you one thing. There are 2 interstellar missions by chance. Voyager, launched in 1977, is actually interstellar. It's outside the solar system. It's going very, very slow. Before it reaches a star, it would take 200,000 years for this to reach a star. So we do have an interstellar mission already, and this is what, there's 2 groups, in the Icarus Interstellar. These are people that are thinking of ideas of getting out there. Chemical rockets don't work. you have to carry more fuel than all the Earth has. There's not enough to get you there, so the energy. Hydrogen bombs, yeah, you could. You could explode hydrogen bombs. All the bombs we have, it'd be a good way of getting rid of them, and use it at the back of your ship, but then you have radioactivity and you have danger for the people living in the spaceship. So that's not a good way to do it, although they're available. One way is to use fusion engines. And fusion engines would get you about 10% the speed of light. This is feasible today. And they would use what is called a substance called tritium, heavy water. And you could get that from the moon. So this is the feasible system. Tritium is, by the way, the most valuable substance on Earth. There's only 10 grams of it exist. It's also very radioactive, and it's used in bomb devices and things like that. Antimatter matter, that's the most efficient way. Matter and antimatter annihilate one another. You put a piece of matter and antimatter, boom, it turns into pure energy. E is equal to mc squared. The m is the matter antimatter. Trouble with antimatter is that you have to put it in something, and that's the containment field. That is being worked on, though. This is an antimatter ship, very efficient, and you could get it from, you could collect the antimatter from reactors. Ramjet fusion is you go in space and you collect, this is 10 miles across, this thing here. So what this is doing is kind of a big funnel collecting the hydrogen gas that's in space and then ramming it through this jet. So this thing is huge. It's not, you know, this is a giant thing. This is the size of the island here. So this is a huge device, and making this is really hard. But I wanted to show it because these are capable of going 20% the speed of light. Solar sails, they're good. They get you out of the solar system, but they're slow. So maybe use a solar sail, and then you'd use a ramjet or something like that to get out. Space elevators is a cheap way of getting material off the Earth or off the moon into space, and they're being developed. So all these things are kind of engineering projects that are being developed, and in the next 100 years, this is feasible. And why do this? Well, there's another way. This is warp speed. This is when you bend space and time. This is what Star Trek did, and you warp time and space, and you travel that way. And so this is actually, someone is working on this. I don't know if this is going to work. This gets you there fast. And the program I work on is kind of elaborate too. It's hollowing out an asteroid. It's taking an asteroid, mining it, selling the material. Asteroids have enough gold that you can make a fortune. Gold and rare earths and stuff like that. So you mine it robotically, you sell the material to make it cost effective, you hollow it out, and then you make a habitat in there. So the program I belong to, and this is, I'll never see this, but the program I belong to is called Star Voyager. And you can find it on the web. And this is an asteroid that's 2 miles by 1 mile. And inside of that is hollow, and it's using a fusion reactor. And this is how it looks inside, a complete habitat. It's like a traveling ecology. You have it will have artificial sun and plants and things like that. And you just take your environment with you. So if you don't find a good planet, you know, you just find a good star or you move on. So. And that's the booklet. Now, all STEM programs relate to this. I mean, STEM is the sciences, as astronomy, biology, physics, propulsion physics is really important, chemistry, medical sciences, because if you're going to travel, you need to have, you have to bring everything along. It's like a really long journey. Technology, of course, designing these things in space. They're not built on Earth, they're built in orbit or they're built on the moon. You can't build them here, it takes too much. Propulsion, energy, engineering, all kinds of, so it takes everything. And for the Caymans, business and investment, we have people who are raising money. This could be cost effective, and actually will be. In the future, when this happens, when there's colonies on Mars and the space station, there's a lot of money to be made out there. And it's called the space business model. That is, in 20 to 30 years, there could be another system of finance here. When this, for example, gold. I don't know what will happen with the price of gold, because these asteroids contain more gold than the Earth does. and starting to mine it brings in a lot of money. And I'll end this with pros and cons. Let's do the cons, why you shouldn't do this or why you can't do it. Well, it's a high price. You're talking like $3 trillion. US dollars, so a little bit higher in Cayman dollars. So you need a huge ship and for this. Also, we don't have the political and science motivation at this time, going through recessions and things like that, but maybe in the future. Technology, you do need new technologies. The major one is propulsion. You really want to get to 10% or 20% the speed of light so it doesn't take 500 years to get to Alpha Centauri. You can go 10% the speed of light now with existing technologies. So the motivation to get there. Surviving the long trip. This will take 50 years. It might take 200 years, so you need to have generations. You have to worry about all that. And finally, let's do before I end this now, let's look at the pros. The pros is survival of the human species in case of a catastrophe. And there could be catastrophes, such as 65 million years ago, the Earth was hit by an asteroid, very near to here, and wiped out 95% of all species on Earth. That could happen again. We could have plagues. We could have viruses that are made. So what you want to do is have a colony somewhere else. Not necessarily on another star, but definitely Mars is feasible. Mars is feasible to have a colony self-sustaining. As you go there, you can live. You can get water from inside because there's ice. You can refine the surface to get oxygen. The soil is just rust. It's iron oxides. So you refine it and make oxygen. And it's good enough to live. So we could have done this now, except for putting it off. It isn't that expensive. So Mars is the first step. What's the other one? It would be exploration, inspiration, curiosity, discovery. That's what humans do. They explore and look for new frontiers to conquer. So I would go Mars colony first. The survival of the human species, the only case would something happen to the sun, then you'd have to leave the entire solar system. We have 1 billion years to do that. So the motivation for leaving to another star to save the human species is not immediate, although the Earth itself could be immediate. You never know when a comet will come in and strike the Earth. You do know, you'll have warning, but I mean, that's a dangerous thing. A black hole, one of these rogue planets I told you about, could be traveling right toward us. I say could be, it probably isn't, and that could disrupt the solar system. That is, it could run into the sun and cause some problems that would make it difficult to live here anymore. And the bottom line here is this one, creating a new space-age economy and a better Earth. This is surprising. I mean, I was not a member, I wasn't sold on this until recently. So what I wanted to quote you is one of the people. Through reaching for the stars, humanity will incite a new era of thought and capabilities with the potential to transform our culture, our technology, heal the Earth, because we'll find all kinds of new things and technologies that can be used on Earth, like the cell phone, like the things you're using today are space age. And I wanted to mention before leaving this, for every investment of $1 for technology development, in today's world you get $40 back. So this is why they're optimistic about this, is that this is a new era that might begin in 10 to 20 years, and it could be a new era for the world and for you. So to heal the Earth, to enrich human experience. This is by the president or vice president of the Icarus Foundation. So I also wanted to mention unemployment. Astronomers have an unemployment rate of, guess what, 0. Well, unless I lose my job by coming here. Maybe I was fired because I came here for a week. But the unemployment rate among scientists in the US is 3%. And astronomy, it's 0%. I'm sure there's somebody who's unemployed, but when you get down there, not a lot of them are in astronomy. Some are in banking because they learned how to do numerical simulations and stuff. So this is a new technology, a new world that's waiting. And and the younger people in the audience will be able to be part of it. So yes, there's 50 billion planets. Some of them are going to have life, some of them might have intelligent life. One is nearby, and who knows what will be found. So this is I'm ending. Sorry, went over 5 minutes, and wanted to thank you. Questions or? Okay, let me do that. Yes, we're running late because of me, because of all of us, and I can answer questions during the break. Some of you might have questions, especially the younger people, the ambassadors. Okay? Thank you.
Okay, thank you, Dr. Guinan, for well-presented presentation. Unfortunately, we are running a little bit late, so we'll forgo the question Q&A, and we'll probably try to incorporate that during the break time which follows. But at this time, I'll call Dr. Alan Young, the Dean for Academic Affairs, to introduce our next speaker, Dr. Hack.
Good morning. I know that some of you were here last night while Dr. Hack spoke. As a matter of fact, she talked about Carl Sagan and Richard Feynman, and I'm sure you'd like to hear what she has to say. There's a whole lot of information about Dr. Hack, and I'm just going to read a little bit, and then I'm going to call her to the podium in the interest of time. Dr. Hack is a senior lecturer and astronomer in the Department of Physics, Faculty of Science and Agriculture at the University of the West Indies in Trinidad. She has said that her interests in science at the time came at the age of 5 by looking up into the Great Dome, not this one, the one outside. Dr. Hack, as I said, is senior lecturer and co-founder of Caribbean Institute of Astronomy and is currently pursuing an MPhil in psychology at UCCI. Dr. Hack's research began in theoretical astronomy and cosmology and quasars with modeling and statistical studies. I am sure she is the person that can pique your interest, having listened to her last night. And I noticed the similarities between her and Sally Ride last night, because Sally Ride quoted Carl Sagan. She did as well. So without further ado, Dr. Hack.
Okay, thank you for that wonderful welcome. Ed, especially to you, but I'm going to need my 2 hands to do this. So. And to all of you, live long and prosper. Right, to all us Trekkies out there. Okay, well, Ed took you far into the reaches of space and really wonderful things, and I'm going to bring you right back down to Earth. And even more than bring you back down to Earth, I'm going to bring you right back to home, the Caribbean, where physically all of us are here right now. So I'm taking a different turn from what Ed just presented to us. Ed showed us the visions of the future, where all of us can strive and reach for, and future, and in terms of astronomy, time and space totally have different meanings. He calmly said that 100,000 years is not long, right? Duh, right? Sometimes our presentations are too long. So let's just kick right in, and I'll try and keep a short presentation. As the previous speakers and those that have introduced us and the ministers and the president of UCCI have all indicated, one thing we know for sure, our world is changing, and it's changing rapidly. You can barely keep up with what's the next model of the iPod and the Blackberries on the market, right? That's how fast, and the next piece of technology. And the people who handle it the best are the young folks. All right, the technology almost comes naturally to you guys. How many people here have to help their parents with the computers? And so, see how many parents help their kids with using technology? Not, right? So we just made a point. The future belongs to the youths. All right, so here we are in the Caribbean. Our circumstances different from the rest of the world. And the question is, do we in any way control our own destiny? This is the pointer, this one. Just checking which is the pointer. This button? Okay. Right, yeah, got it. So, do we control our destiny, or are we simply at the whims and fancies of all that's happening globally? We are a unique area of the world, and what is our best resource, right? The previous speaker spoke about mining the asteroid for gold, right? Business plans, ching ching. What is our best resource? Our best resource is sitting in front of us, and some of us a little further along in that, and our absolute bestest resource are the young people that are sitting in this crowd. Now, what's wonderful about this conference, which is not always what you will see, is the mix of the older people who are showing a vision to the younger people that you will take forward. And that's an amazing and a challenging thing as well, for us to be able to speak to two levels of audience. So our greatest resort is us. And as this conference is trying to push to you, and that is STEM issues, science, technology, engineering, and maths, in a single word, the scientific mind. The scientific mind, the science, is a critically thinking mind. And a critical thinking mind is a problem solver. At the end of the day, the humans as a species have survived because of problem solving. Okay, so there are those that create problems. So as they say, are you going to be a part of the problem or part of the solution? Right? Everybody here is part of the problem or solution. Solution, part of the solution. And that's what universities are about. That's what this place is about, right? Solving problems. So we've all seen that far too many times. That's what the Caribbean area looks like. But that question of what the Caribbean is not as simple as you think. Every time I try to get a definition of what is the Caribbean, how many islands belong to the Caribbean, I end up with different answers. There are all kinds of definition of what the Caribbean is. Then the world often lumps us as Latin America and the Caribbeans, almost wiping off what, in my mind, is the Caribbean, because Latin America is way bigger in extent than the Caribbean, let's get back, right, the Caribbean that we see around here. So I'm going to give you a little overview, but on the global scale, it's called LAC. Anyone who's involved in these things would immediately recognize what LAC means. It's Latin America and the Caribbean, and it's treated as a region by itself. And when you do that, it actually creates some problems for us islanders. So let's just get the Wikipedia definitions out of the way. Critical thinking, really, it's all about being able to problem solve. That's what I would say briefly. And with it, what does it mean? Some of the skills you find, and this is what we want to create in our students. Okay, students, am I losing you guys? You're with me? All right, so I want you guys to talk to me also. What are the stuff that you're doing in school? What do you like to do? Okay, so you want to be able to reason, evaluate, analyze, make decisions, solve problems. There is something missing in there in some of the things that we do at school. What's missing there? Anybody ever, do you know your timetables? Did you have to learn your timetables? Yeah? And how do you learn your timetables? You? What do you do to learn timetables? You got to, somebody's saying it, you got to memorize it. Okay, it's just an example I pulled up. The whole point is that under critical thinking skills, let's get back here. Yeah, under critical thinking skills, memorization is missing. All right? Because that is essentially what we find over the years is regurgitation. We can memorize something without having a clue or understanding how it works. And there's a little quotation from Confucius, and maybe it's Confucius, but it goes something like this. What I hear, I forget. What I see, I remember. What I do, I understand. So right after I'm done with my presentation, you're going to forget all about what I've told you, all right? But once you get your hands onto something and you work on it and you understand it, that stays with you, all right? So memorization and regurgitation is not something that we wish to encourage under a critical thinking nation. Well, I'm going to read that for you as it's lost a little bit in the blue. This globe of ours is inhabited by 2 species of humans. Of 1/4 of mankind, some 1.1 billion are developed. They inhabit 2/5 of the land area of the earth and control 4/5 of the world's natural resources, while 3.6 billion developing humans, les miserables, and the mustazafin, meaning deprived ones, live on the remaining 3/5 of the globe. What distinguishes one species of humans from the other is the ambition, the power, the elan, which basically stems from their differing mastery of present-day science and technology. Right? Anyone recognizes this gentleman? That's Abdus Salam, Nobel laureate in physics and founder of the International Center for Theoretical Physics, and spent his life working on for the developing nations for the progress of science and technology. So, critical thinking through scientific research and education is the key to societal development and growth in the Caribbean. So there are 2 areas. So the rest of my talk is about looking at where the Caribbean stands in scientific research and then in education, right? And like we said, we have the young folks here. I share a few words from a book by Malcolm Gladwell, The Outliers, The Story of Success. Has anyone here read that book? All right, okay, I thought it was a pretty excellent book. And those of you that read it, and I will share this secret, the author, who actually originally happens to, at least is half Jamaican, and that was an interesting thing to discover about him. He works through the lives of many successful people, and he comes up with a magic number. Yes, Roy's giving away my punchline there. But indeed, very correct. The magic number for success is 10,000 hours. When he looked at many, many lives and you track it, he realizes that, yes, success is partly talent, but that's not all that makes people successful. It is 10,000 hours of slaving, hard work, dedication, committed to one focused effort that makes people a success. So if you track the life of Bill Gates, Steve Jobs, a whole number of people, those of us that have enjoyed the book, see that it comes down that they have 10,000 hours behind them. So when you think that Facebook guy, what's his name? Thank you, right, Mark Zuckerberg, right? He's a young chap, and you're thinking, wow, what a genius. These guys are so young. But when you track their lives from the time they were 10, 11, 12, 13, 14, all they are doing is they are behind the computer, they're programming, and they are clocking their 10,000 hours. When you have a successful dancer and a singer, it doesn't happen overnight. You start with some talent, but the hours and hours of practice it takes to reach the pinnacle of success. That's it. If you have a successful scientist, they have spent years and years wondering, thinking about what they're doing, right? Clocking their 10,000 hours. So from the book, he mentions who we are cannot be separated from where we're from. And it brings an interesting aspect to what makes a success? Well, one aspect is 10,000 hours of expertise. The other is culture. You cannot separate culture without, if you want to totally understand a people and what their successes and failures are. All right? So a few words from his book again. Cultural legacies are powerful forces. They have deep roots and long lives. They persist generation after generation, virtually intact, even as the economic and social and demographic conditions that spawn them have vanished. And they play such a role in directing attitudes and behavior that we cannot make sense of our world without them. And if any of you travel around the Caribbean, and Dr. Packer Claude is here from Jamaica, and if you go to Trinidad or you go anywhere in the island, most Caribbean people could immediately say, you're from Jamaica, man. Or when a Trini talking, you could recognize a Trini anywhere. And we are all in just one area. Or when the Guyanese comes, okay? So culture is defining us. Right? And even within the Caribbean, we talk about, you could tell what the Jamaicans are going to be like, or now we would know what the Caymanian person would be doing. You can almost predict. And while the histories, and Roy is a historian, will tell us we had some commonalities, but each was still unique. And that history is still directing how the island behaviors are. Within Trinidad, well, that's where I come from, you could tell somebody who's from South Trinidad from who's from North. And I was asking our organizer, Bill, could you tell a difference between South and North Caymanians? And he's nodding to me. Could you imagine that? A population of 50,000 people, a speck in the ocean, and yet where we come from affects us in all that we do. So in this region, science is not ignored, has not been ignored. I've thrown some logos up there from Caribbean societies. NEHIST is from Trinidad. Then there's the Caribbean Academy of Sciences. There's the Caribbean Science Foundation. There is CARI Science, and you've got all these things. It all looks nice and wonderful up there. One funny aspect of all the logos I showed you is that almost all of them actually originate from Trinidad, all those societies. And when I think even further in it, it's just that because I happen to know the person, it's almost the effort of one man, right? I don't know if some of you know of him, Professor Harold Ramkisoon, mathematician, okay, and big pusher of science and technology in the region. Currently, he's a senator in the government in Trinidad. But it also makes the point. Sometimes you feel that, hey, how could I make a difference? I'm just one person. All the people that ever made a truly significant difference in humanity were often one person, right? And that's when the names begin to stand out, the Gandhis and the Albert Einstein and things like that, okay? So never think that you, as a single person in the Caribbean, cannot make a difference. So what does our Caribbean picture look like? So under research, I grabbed some data, put it together for you. Over a 10-year period from the Web of Science, 32 Caribbean countries published 12,817 papers. We just heard that Ed by himself published some 500 papers. He's blushing, okay? So it just gives you a feel. It's a 0.08% of the world total, and that 0.08%, Cuba produced half of them, so that leaves 0.04 for the rest of us, and of them, Jamaica and Trinidad, 10% each, so that's about 0.0. So you start to see, it starts to get really, really tiny for the individual islands. The Caribbean has made impact in these areas. Agriculture, biology, environmental sciences, 28% of those research publications came in those areas. Biomedical research, 21%, and clinical medicine, not bad. And the islands, I'm just giving you a Caribbean overview, that stand out in these areas. So agriculture, biology, environmental science, Curacao and Bermuda show the highest visibility, while Belize, right, you get the specialization. Now, this is what I was talking about. On the world scene, you think of the Caribbean, Latin America, Belize, the definitions really vary. Is it just the islands? Is it from here? Is it here? How do you define what are the countries that make up the Caribbean? And they vary. They vary according to the studies. So in some cases, you've got Curacao, you've got Belize, right, Bermuda. Biomedical research, Barbados and Bermuda, they lead the way, right? And Grenada also shows a lot of specialization in this area. Chemistry, Trinidad and Jamaica have done a fair amount of publications in these areas. And clinical medicine, with by far leading ahead of the others, is the Dominican Republic and Haiti with respect to the, well, visibility or citation of the publications. So when you look at a division of, actually this is the Science Citation Index over 1973 to 2010, so we're almost looking at 3 decades there, sorry, 4 decades, 40 years. Over that period, you're seeing the division among the world. All right, so Spain comes out front, Brazil with 21%, Mexico, Argentina, and the slice of the pie is getting smaller and smaller and smaller. Okay, so you can still see some of them: Chile, Venezuela, Colombia, Cuba, etc. Jamaica makes it out by themselves. And then we've got the rest of Latin America and the Caribbean lumped in a 1% of the pie. And in that study, those are the countries that are considered. And I know you're really worried, is she now going to read all of them out one by one? I'll spare you. Okay, so the listing is there. You can see. So you can see how much of it is Latin America and how much of it is Caribbean in terms of the islands, right? All grouped together. So the countries, the regions that were in the front with the research, was there a commonality? I started myself, is there a common feature in all of these areas? And I did come up with something. There was some tertiary level institute in all the islands that were up ahead with the research. And it's just a listing, not gonna, right? You can see it for yourself. University of the West Indies is one of the leading ones in the region and has campuses in Jamaica, Barbados, and Trinidad. Belize has a very famous university, University of Belize, and you've got all of these areas. And then what you find is places like Dominican Republic, Haiti, Cuba. They've got, in cases, well over 20 universities just on their single islands. And you find, therefore, the research output is tremendously more. Grenada is a tiny little island, and yet it was forefront with publications in biomedical research. Well, St. George's University is there, right, which is a pretty good university for medical research. So let's just jump over to education. And this is Nikki Bogle. Actually, she's the founder and CEO of Caribbean Education Foundation. And her message is, educate one child, empower a community, and transform our world. We are small. The Caribbean region is a small region. The population, what's the population of the Caribbean region? Anybody wants to ballpark it? I know the historians and the academics probably know the number. What do you guys, or let me ask the young people, do you want to guess? Well, how many, what do you think is the population of the Caribbean region? Okay, right, Cayman is about 50,000. Right, okay, what do you think is the population of the smallest island? Let's take Montserrat. 2,000, right? It's pretty much on the ballpark. It doesn't exceed 5,000. And as a matter of fact, I am so amazed by your other Cayman. Cayman is 3 islands, right? There's Little Brac and the population of those islands, okay? But you are still a group. But you've got Montserrat, you've got St. Kitts, and these are countries. These are countries with populations of just a few thousands. Jamaica is significantly bigger, but ballparking it, the population of the Caribbean region, folks, is 8 million. What's the population of Chicago? Sir, any idea? Chicago? Yeah, it might be about 10 million. Or any, well, right, you're from the US. Any major city in the US, New York and so on, would be of the order of 8 million, 10 million. And let's not even go to Mumbai and China. Okay? So I'm trying to bring you a perspective. Ed showed you the perspective of how big space is. I'm bringing you the perspective that while we live here, we are a very small region. The entire region is no more than a city in some countries. So I'm going to mention a little bit of some of the work that we were involved with. So my area is in physics, so it's specific to physics, but I think it speaks for all the sciences. So about a year or so ago, we got into a program where we started to review the physics to see if what level of critical thinking was involved in it, right? So we talked about critical thinking. We did this in Barbados and in Trinidad. Well, the CXC headquarters, they're in Jamaica. Well, they're in Barbados actually, but they have a big arm in Jamaica. And we worked with teachers in those two islands as well as students. And what did we find? When you do a study, one way of putting things emerge, if you're ever part of any stakeholder engagements trying to get information, truths, trends, and unique ideas emerge. A truth is something where the bulk of the people are saying it, and you better listen. The story on the ground, there's often a lot of truth in it. So these were the truths. These were the things that bulk of our respondents said. They said that in the schools, the infrastructure of information technology and the equipment was inadequate. The teachers said that the students were not employing critical thinking skills. The mathematical skills were very poor. And I know we'll be dealing with mathematics in some of the other segments. In addition, English skills are very poor. Now, you might think, what does English have to do with science? English has everything to do with everything. Because if you cannot express yourself, forget it. If you cannot write a paper, a scientific paper, if you cannot explain science to your class, if you don't have a good command of English, you've lost half the battle. When I say English, it doesn't matter which language. It could be Spanish. It doesn't matter. It means the ability to communicate. And our students' ability in English is getting, I don't have to say if it's changing or if it's getting poorer. Because once upon a time, you spelled your as Y-O-U-R, and now my students would write me and go, you are, right? And it took me a long time to interpret what LOL was. That was some time back. For a long time, I thought it was lots of love. And I was like, oh, okay, everybody's, signing off so nicely to me. So today I know it's something else. The whole thing is that very quickly, language is evolving. And those of us teach sometimes are not on the same page or the same Facebook page as where the students are. All right, so, but to be able to express yourself, we cannot ignore this for the sciences. Right? SBA is school-based assessment, which is used in the Caribbean examination process. It was felt that this was very good for critical thinking skills. And over, the teachers told us, we don't have enough time to complete the syllabus, so we can't do critical thinking. We have to give the students all the material, and the students memorize it, and they learn how to pass exams. Watch what I said. They learn how to pass exams. You take that student and you put them in the workplace, and you may find a disconnect, right? So we talk to employers. Employers say, sometimes our graduates are coming out with great degrees on paper. You put them on the ground, the performance is not there. Where's the disconnect? Problem solving, critical thinking skills. So we have to assess. I see people who are in education to understand, knowing what I'm talking about once you're involved in it. So those were the truths, the trends. These were things that generally a fair amount of people said. That the students' grasp performance in physics was getting worse. And like I said, I think it can safely be extended to the other sciences. They felt that the practical aspect of physics should be the most important part, and schools lacked the infrastructure. We didn't do the study in the Cayman Islands, but in the other areas we spoke. And yet, what the students enjoyed most was the practical aspect, hands-on. What you do, you understand. So we must focus more on that. And look at this interesting thing. Students, that be who like physics and enjoy physics, prefer to do problem solving, and those that don't prefer memorization. Isn't that interesting? Okay, so these were questionnaires. We found all these trends, and we also recognized that the school-based assessment had some difficulties by its very nature, although it was a very positive thing for critical thinking. For those that are a bit confused what school-based assessment is, if you're not part of that, that is, if it's like in a lab-based course like physics, those are a series of experiments and projects and so on that students will do during the semester under the guidance of a teacher. So you get that critical thinking and problem solving, and then they put it together as a notebook, and that's what creates part of the examination. So it's school-based assessment. And that, why we have that note there that it had some difficulties by its very nature is because we found in cases that teachers were doing a fair amount of it, and you're not getting a reflection of the students' work, but not in all cases. Nonetheless, there's far more good than bad, and we must never throw out the baby with the bathwater. Some of the unique ideas that came from students and teachers: implement a practical exam, introduce astronomy. All right, students out there, what do you guys think of that? Introducing astronomy into your curriculum. Would you like that? On that side, on this side? All right. Well, you know, you've got Dr. Rudy, and UCCI has a observatory that has recently been built there. So Cayman is well on the way with that, and there are some sessions on astronomy, and before me, Ed also spoke on astronomy. The beauty about astronomy is that you can find every science within astronomy. So take your pick, whether it's maths, physics, chemistry, biology, there's an aspect of it in astronomy. It was recommended there should be more science fairs. Cayman is already doing that. And I know part of our conference here today, we're going to see some of your projects. Increase coursework component, reduce the size of the syllabus, and include Caribbean, well, we have physicists, let's call them scientists, right? And the history of science into the physics syllabus. And the CXC board has been kind enough to take our recommendations, and we've actually done that. Okay, so what you're seeing up there has been recommended to the CXC board, and well, I'm chairing the panel for the review of physics, and we have reduced the size of the syllabus. We are changing the approach, and our next step is now to run workshop for teachers, because you can't change physics. You don't change the content, right? 50 years ago, Ed, when you would have done physics, I'm being vicious here, right? Is the same physics that you are learning today, right? Because that's not going to change. But what we got to change is how we teach it and our approach to it. As much as I emphasized the English, so too must emphasize mathematics. In a discipline like physics, it cannot be separated, and our students in physics suffer for their abilities in mathematics, and for some reason it just seems to be getting poorer and poorer. That's just my analogy, that mathematics is a tool to get the job done. If you have poor tools, you create a poor product. If you have no tools, you can't build at all. So physics, you must have a strong mathematics background. So that's what's going on in the Caribbean. What about the world? How do we compare? Well, there are all kinds of studies, and those of you that were here, actually Sally Wright, in the presentation we saw, did cover some of them. I'll just give you an overview. That Finland is one of the countries that comes out top in science and mathematics. You would hear all the other names too: Hong Kong, Canada, Taiwan, Estonia, Singapore, all these countries come out at the top. And this is to check your vision. I said, let me give you all a little eye test. All right? Don't strain too hard. Even I can't read those things, even if I go right up. But just suffice it to say that what we've got up here is the top ranking country in maths performance. And right at the top, we've got like Singapore and China. And then, well, this is just the US average, it's just a graph. And then you find down here, we've got Mexico, Qatar, Argentina, right? Brazil, these down here. And you can't even find Trinidad, Jamaica, Barbados, Cayman on these studies. They forget we exist, or we need to do the studies and incorporate our data into it. Right? So that's just the trends. So here you've got, again, mathematical skills in different countries, and the international average would be like about there. This is the international average, okay? Right at the top, Singapore, Hong Kong, right? So we're just, and we've got, what have we got down at the bottom? Well, we've got New Zealand here. Okay, it's just to show you trends. Right? More eye tests, international ranking. And now when you look at it, for the same, this is maths and science scores. At the top, so it's just the trends I want to show you. Singapore, Korea, Japan are right up there in maths and as well in science. So there's a strong correlation between your skills in maths and your performance in science. And there you find down here, what have we got? We got Colombia, Kuwait, Iran, Portugal, and so on. Cyprus, a couple of different countries, these in the middle. Back to the issue of culture. These are statements. We make these statements all the time. And then there are truths. When someone is saying something all the time, there's an element of truth in it sometimes, right? Unless you're spreading rumors, as somebody said at the top, right? Asians cover many more topics. Japanese are in school longer. The French require more homework. And the Chinese students are well known for how well they can do mathematical calculations. The important thing to note is that around the world, there's a lot of attention being paid to science education and maths, right? And that's what the STEM conference is about. So we are now there. So what is our Caribbean culture? Well, this is what brings a lot of tourists to us: sun, sand, sea, and nobody knows how to party like we do in the Caribbean. Right, folks? Right, I'm seeing the heads shaking, okay? And there is a wonderful thing in that we know how to party. We'll probably have less stress, live longer, and be very happy, easygoing people. But sometimes it comes at a price. So what's our culture in the classroom? Can't quite find any studies to cite for you, but I could speak from experience. I've been teaching in the Caribbean for a long time. And I studied in the US, so I've engaged with students in the US and all over. And there is a big difference. The Caribbean students, I find, are quiet, they are laid back, they are more docile. They will not challenge you. They do not ask as many questions as you might find in another environment. I don't have any studies to back that up, except that that's what I have observed over and over. And we must ask the questions, is there a reason for that? And if there's a reason, it would be based in culture and history. Okay, so it's something we need to look at. So we need to get that inquiry and questioning and not being afraid to ask a question. All right? I practically have to beg my students. I'm like, guys, nobody's going to know. Either you're wrong or you're wrong. That's fine. The best thing that can ever happen sometimes is that we make a mistake. Best learning occurs from making mistakes and then going on the right path. Along with this, trying to push science in our region, I just mentioned briefly here some of the work that we are doing. These are 3 science documentaries that me and my team have produced, and this was released in 2008, Adventures in Discovery. Its motivation was to show the science our Caribbean people are doing. Then we released All Is Number in 2010, and we have just released Losing Paradise. And it's about us, because you put on the television, you put on Discovery Channel, you put on the TLC, whatever channel, History Channel, and you can get all that's going on in the world. Where do we find what's going on in the Caribbean, right? So we have a responsibility, and you kids have a responsibility, right, to do it for us. So Finland stands out in the world as one of the leading nations in their educational program. So what is it that they do? So I'm just going to highlight what they do, and I have among us many educators, students and educators, and you got to see if that's what we are doing here. Well, the Finnish school system uses the same curriculum for all students. Look at this. Students have light homework loads. Students, Cayman students, how's your homework load? Do you guys get a lot of homework?
Yes.
Did you guys finish your homework for this week?
Yeah.
Oh gosh, we have got good students here. Would you say your homework load is heavy, guys? I'm seeing you guys shaking your. Wouldn't we all love less homework? All right, teachers, hear that, huh? The students want less homework. They do not differentiate their students. There are no classes for gifted students. All the students are in the same place with the same curriculum. They don't do standardized testing. We do these things we do in Trinidad, by the way. Lots of homework. We do have schools that are prestige schools and non-prestige school, if I may say so. So we do not do that. Children do not start school until age 7. Would we not be absolutely appalled at that in this side of the world? And I was in Finland, our collaborators are there, and I was most appalled. I was up at the observatory to see it was summertime and children are just running helter-skelter through the observatory, and it's not disturbing anyone, and everybody's just going about their work. And it was so wonderful, because in Trinidad, if we bring our kids to work, okay, first day, your staff will be polite and this and that, but you can't make a habit of it. You can't bring your kids to work. Okay, but in Finland, the culture is very different. The children are allowed a freedom to roam, to be curious, to investigate, and they didn't start until age 7. Just by the way, because I myself come from another country, born in a village, I didn't start school till age 7. I was not speaking English until after age 7. All right, so Finland has a comprehensive preschool program and so on and so on. They don't even give grades, right? And nor do they put children as first, second, and third. So far, all that I've looked at, I know we don't do that in Trinidad. All the teachers must have master's degrees. So they've now focused on the teachers. Now, here is what's interesting. Being a teacher is highly competitive. Now, you see, it's what society puts value on. If we put a value on that the best things to be are doctors and engineers and lawyers, that's what we all want to be. If parents tell their kids, why do you want to be a teacher? We've already sent signals to them. And yet, maybe that kid could be the best teacher and make the greatest difference that anybody could, okay? So it's what society is going to choose to put value on. So look at that. Just 10% of Finnish college graduates are actually accepted into a teacher training program. I teach physics at the university, and one of the issues that students come to me with is, well, they call me Miss. Miss, all you could do with physics is teach. And I'm like horrified. Absolutely not. There's so much you can do. And students sometimes have a perception, well, if I can't, there's even this saying that goes around that says, if you can't do, teach. How horrible. Okay? Because teaching is one of the most noble of professions, and that's what changes societies. All right? So just the lessons from the Finnish program. Students are separated into academic and vocational tracks during the last 3 years of school. Look at that, 50% go into each track. Now, you must bear in mind the social background for the Finnish structure. It's a socialist country where the difference in salary between a teacher and a professor may not be that much. In a system like that, you then do what you love. Right? If it's not necessary that everybody's got to be a doctor and nobody should be a plumber, because the difference isn't that much. Maybe someone is absolutely skilled and could be the best plumber that anybody could be, and this allows you that. So it's a different structure. We do need to keep that in mind. Just to pick up the few main pieces here. Groups of teachers visit each other to observe their colleagues at work, and we were having an interesting radio talk yesterday, and I thought, I don't know how we're going to be on radio for 2 hours, but it went in the blink of an eye, and all of these conversations came up. You'll hear from Dr. Packer later in the day, and Roy was there also. All right, and these things came up that teachers do need to do peer teaching, observe each other's work. Teachers get 1 week off, 1 afternoon a week for professional development, and there is this, college is free in Finland. As I said, those things, of course, are by nature of the country itself. So just want to touch one more thing, the issue regarding STEM of gender issues, male-female issues. I could find no data for the Caribbean. So those of us that are in academic institutions, there's lots and lots of research for us to do and publish, okay? So among genders, but still, see the trend, it's a screaming trend. And what you will see here is how many females, right? It's just the breakdown of who are in science, technology, engineering, maths, trade, areas versus non-STEM degrees. So I don't have to read much for you. It starts as far back as the baby boomers, some of us baby boomers, Generation X and millennials, but in every case, women in the science streams are far less than in the non-science streams. And that we could be pretty certain is patterns we may see. I don't have the data for the Caribbean for this. Okay, so we do need to encourage our girls, empower our girls, right, into science and mathematics. And similar kind of traits, percentage of people employed with the STEM degree holders actually working in those fields, right? So you find again, the trend is screaming, so I don't need to go into it, that the women are always in fewer STEM areas than men are, okay? So that's telling us something. So we could just wrap that up and say that while times are changing, right, the gaps between men and women remain vast, and they are only now closing. So educators, people in influential positions, you must keep the field in mind, our playground, and we must encourage our girls into science and mathematics. Just want to, so I'm just taking different aspects of around the world scene and what goes on. And I call this the Ramkisoon Report, which is same Professor Harold Ramkisoon, a paper that he did. And I'll just highlight the main things. All that is saying up there is that how much of a country's GDP is dedicated to science and technology and how that reflects in its development. And again, the numbers start to scream. Every time a country increases its percentage of funding, of percentage of the GDP into science and technology, you get a huge jump in how the country begins to perform. So Costa Rica and Cuba went from 0.2 to 1.25, and I already showed you that they are the leaders in the region for performance in science. Cuba allocated 1% to research and development, and it gets 10% of its income from biotech exports. And in the region, by 2000, no country in the Caribbean was actually spending any more than 0.2%, and that's the Caribbean islands that we are talking about. And in some cases, there was absolutely 0% allocated to research and development. There is a magic number. There are always magic numbers, 10,000 hours, you know, and the magic number is 1%. A country should at least have 1% of its GDP dedicated to research and development. And all the nations that you find progress in, that number jumps out all the time. So the US and Japan spend 2.8%, India 1%, China 1.2%. And what you find is that the entire amount of the GDP on research and development in all the Latin America and the Caribbean was equal to what South Korea alone was dedicating to it. So all these things mean is that there's a very, very strong correlation between investment into research and development. I could change this into STEM, right? These are just buzzwords. If something is, before we said R&D, but essentially it is STEM. So with that overview, what's unique about us? What are our problems? Well, like I said, you can't quite define what is the Caribbean, and the picture changes in terms of how the Caribbean is defined. Then each island, we have our own cultures, our own strengths and weaknesses. And you might wonder why I put the vast seas. Let's put it this way, and a lot of things come from personal experience. In Trinidad, and we are like the most southerly island in the Caribbean chain, it's easier for anybody to go to Miami than to go to Barbados. From something as simple as the ticket, it might be maybe 300 US for us in Trinidad to go to Miami, and sometimes it's like 500 US, right? These days it's a bit lower, but I'm telling you, a ticket to Barbados, an island that's so close to us, is more expensive than to Miami. So money drives everything. So where would we go? We go to Miami to shop, we go to Miami to do all our stuff. And you find that. So rather than turning to each other, one of the presentations is going to be by my good friend, Graham, on Carina. He represents Carina, Caribbean Institute of Astronomy. And one of the things, and I was with them some time back, one of the biggest challenges was outreach into the Caribbean. And cost is the factor. It costs to be able to physically be in the different islands. And yes, there is Skype and there is email and there's all that stuff. But come on, folks, we all know nothing beats good old face-to-face. You absolutely need face-to-face, right? Anyone who has had a meeting by these high-tech things will know that experience. It's just not the same. So we're a very complex region. And don't underestimate this part. And this is where the problems occur. And I tried to show you that the world sees us as Latin America and the Caribbean. Well, the bulk of Latin America speaks Spanish. So how can I collaborate with colleagues who are doing all their work in Spanish and I could barely say more than hola, gracias, sí, right? So the language is a big barrier. And therefore we must learn to speak Spanish as well, right? And that kind of too, so that we could all communicate. So these differences, while they make us unique, also divide us. If we come together, we are all stronger for it. So while those are the problems, there are always solutions. And this is what this conference is about. It's about creating critical thinkers through STEM, right? Research and education. And the STEM, literally, is what will give birth to ideas. So I close off, and of course, well, all of that is to take the Caribbean workforce to higher performance levels. And there's the good old, I started with Carib, and I end with Carib, and you'd be surprised to know that I've never had a Carib in my life. Okay? Again, stealing from the Outliers, the Story of Success, a book I do recommend you read if you get a chance. Success is not a random act. It arises out of a predictable and powerful set of circumstances and opportunities. And at this point, I speak to the leadership that are among us. I speak to the president of UCCI and ministers and politicians, because they are the people that can create the circumstances and opportunities for our young people to take advantage of them to make us as a region a successful area. Thank you.
Thank you, Dr. Hack, for your insightful presentation. While I sat there and you talk about the many countries that were ahead of the US and various countries, I researched the latest, I think it was the 210 figures, and China is actually on top, and then South Korea, and Finland. And the funny thing about it is that last year I had the opportunity of going to South Korea, and I wanted to find out why is it that they are at the top or close to the top. And I saw kids going to school when our kids would not be going to school. They were at school until 7 at night. So I'm not saying we should do that, but I want to thank you for your very insightful presentation. Now, I know we are running a little bit behind, so I'm going to sort of commandeer this a little bit